Project L and Project L of Math 120, and it pertains to what you're learning in Math 120. And what are you learning in Math 120? Well, you're learning about conic sections. And over here, I want to claim to you that I'm looking at this problem over here, and you know, I'm going to say that you should be able to graph these conic sections by hand. And certainly, if you go over your Math 120 notes, we did do this by hand. Now, what I'm noticing about this over here, there's two conic sections. What they want me to do, though, is find the point of intersection. This is a system of nonlinear equations, by the way. They're quadratic in form. They're both conic sections, by the way. So what I want to do is I want to, kind of experiment with this. And what I mean by that, I'm going to open up Sage. I already have it running. And what I'd like to do is I'd like to, see if I can handle this without looking at the code. So I'm going to say reset. I'm going to say X and Y are variables. And what are the variables? X is a variable and Y is a variable. Just typing that in for you. All right? And again, you can look at the code. I bet that I have in the code. The next thing I'm going to say, equation 1 is equal to x squared minus 4. Yes, you must use the star. Y squared minus 10. Yes, you must use the star. Minus 64 star y minus 247. And that equals double equal sign, right? That equals 0. All right, equation 2, EQ2. Again, I don't know if the code looks like this, but my suspicion is because I do write the code. And not that I don't vary my code, but it's typical of me as I define the equations because I don't have to keep retyping them over and over again. 16x squared plus 4 star y squared, and then minus 160x. And in Math 120, this would be the section on conic sections. 64 star y plus 400, and that is equal to 0. And what I'd like to do is I'd like to plot those. So I'm going to say plot, P-L-O-T, and I'm just going to do a quick dirty plot, and I'm going to plot equation 1, EQ1, and I'm going to plot EQ2, EQ2. I'm not going to give it any domain or range. I'm just going to say, please plot those two on the same axes. Let's see what happens. And I got a problem here. I'm not seeing anything. All right, let me close that. It's an old picture over here. So let's take a look over here and let's see what happened. So I have to read it. When plotting, failed to evaluate at 200 points. Wow. You know what I'm going to do? I'm going to try to plot one at a time now. This is going to happen to you. EQ1. And let's see what happens over there. Variable y not found. Let me go back over my code. I defined x and y, right? Let's see if I did equation 1. Again, this is interesting. I want to see if I got equation 1 defined. X squared minus 4y squared minus 10x, 64y minus 247. Let me see if I did equation 2 right. I'm just using my up arrow to look back over my code, by the way. Well, I went too far there, didn't I? Let's do equation 2 now. 16x squared, 4y squared, minus 160x, plus 64y plus 400. Yeah, I think I did okay. And let's go back over the plot. Now I'll just type it in. I don't want to go over the command, so just plot. Let me plot equation 1, EQ1. EQ1. Y. X. Now I know why it's not plotting it. I need implicit plot. All right, sorry about that. And again, my mistake. Implicit plot, EQ1. And let me just see what happens over here. I'm missing some arguments. They tell me I'm missing X range and Y range. Let me put that down. And let's put this over here. EQ1, I'm going to put X down. I'll put the range down between, I don't know, minus 20 and 20. And I'll put the Y range down, Y range between minus 20 and 20. And this is just, a dirty picture at this point. And I get a picture over there. So I'm doing better now, at least I'm doing better. All right, I want to revise a little bit. I noticed that, I got a picture over here. It's, hyperbole in nature. But I'm going to, go back over here, and I want to change the range of it a tiny little bit. So I'm just going to go back over here. And I noticed the X values. I'm going to go up to 40 now on the X values. All right, let me go back over here. And I'm just playing around with it. And I like that picture better. But now I'm looking at the Ys, and I'm going to stick between, I'm going to say the Ys. I want to go up to a high of 5 on the Ys. And what I'm doing? I'm playing around with the software. Just playing. I like that picture better, by the way. So let me close out all those older pictures. And what I'm going to do now is I'm going to use this. And what I'm going to do is I'm going to put down, I'm going to store it somewhere. IP1 equals that. All right, now I'm going to do IP2 equals, I'm going to do a copy paste, but I don't want equation 1 on equation 2. All right, now I have two placeholders that are holding two images. I want to add those images together and show it. So I'm going to do IP1 plus IP2 dot show. Let's see what happens. I'm getting it. Now someone says, what are you getting? I'm getting a picture of an ellipse and a hyperbola. So if you look at it, I will say this, I know there's points of intersection, at least there appears to be points of intersection. What I want to do now, though, is solve for those points of intersection. The way I'm going to do that, and again, I'm not looking at code, I'm just playing around, all right? I'm going to solve, and what I want to do, I want to solve a system of nonlinear equations. So equation 1, equation 2, and I want to solve for x and y. And let's hope it does it. It's working on it. And yeah, it gives it to me. Now, by the way, before I go off and say, oh, gee, this is the right answer, I want to look at it. And it says x equals 1, y equals minus 8. Well, I'm going to say, 1 minus 8, approximately this point over here. And when I say approximately, I'm looking at a picture. And this point over here is 9 minus 8. And 9 minus 8 is this point over here, point of intersection. All right? So I want to look at the codes because, we struggled a little bit, right? I kept, trying to get a graph. It didn't graph it. Then I started to realize it wasn't a plot. It was an implicit plot because I didn't solve for y. Right? If I solved for y, it would be using plot. But since I'm not solving for y, it just had an implicit relationship, I had to use the implicit plot. Anyway, I like the picture that got over here better. Incidental, but I like it better because I can read it easier. But I want to go back over the code and see what they did. Yeah, they didn't graph it, by the way, but they get the same answer. All right. So again, let me point out, I didn't look at code. What I did, I'm getting better, but I did make a mistake. You're going to make a mistake too. And when you're getting an error message, don't panic. Look at it. Sometimes they're very cryptic, but do look at it. And then hopefully after a few minutes, you'll figure it out. I really mean that. After a few minutes, you'll figure it out. But if you're the type of person, each time you hit a roadblock, that you're trying to flag down help, this is really bad behavior. You don't want to be flagging down help until you've exhausted all options pertaining to yourself, by the way, including reading the error messages, rethink about what you're doing, and trying to do it on your own. You're going to feel a lot better about yourself when you do things on your own, all right? So that's not bad. This question was actually lifted directly from my Math 120 notes, all right, that we teach at Eskin College in Math 120. Thank you so much.